Kia ora Year 11 and 12. Here are two more questions from last year's algebra exam. So both of these are excellence questions. The first one's an applications one with depreciation, and then the second one is an index problem. Neither of them are too bad. So here's the first one. We've got a computer and it depreciates continuously in value from this initial amount, $4,699, to $1,500 over 4.25 years. And we're told that the value t years after its value was this can be modelled by this form. So we know how to work with that. The a in here is our initial value. So we might as well start by putting that in. We know that y is equal to 4699 times some rate of depreciation to the power of t. So remember, the picture of what's going on here is I buy my computer for $4,699 and tragically its value drops like that. So we know that after 4.25 years the value has fallen to $1,500. So let's substitute that in and see where to go from there. So 1,500 is equal to 4,699 times r to the power of 4.25. First thing to do is to divide both sides through by this. We get 1,500 over 4699 is equal to r to the power of 4.25. And this works out to be, and I'm not going to round it, in the schedule they rounded it to about 4 decimal places, but try not to do that until the end. Okay, so we're trying to figure out here the depreciation rate so that we can use it to solve the next part of the problem. Now, don't be tempted to take logs here. What we've got is something to the power of a number. So imagine if we had x cubed is equal to 17. What would I do to both sides of the equation? Well, I'd take the cube root. So it's the same idea here. You just have to be careful about whether you're looking for something that's up in the power when you do need to take logs, or whether you're looking for the rate. So here we're going to do both sides, put them to the power of 1 over 4.25. All right, so let's look at why that's going to help us. We want to have r to the power of 1, so we need the reciprocal. Okay, so when you chuck that in your calculator, you're going to get out your interest rate. And I'm going to just squeeze it in down here. So r is equal to 0.764388. So a very silly long number, but let's just leave it like that. What we're going to do next is we're going to substitute that back into here and then work out the value after 6 years. So we're nearly there. Y is equal to the initial price, 4699, times 0.764388 to the power of t. So what can we say after 6 years? T is equal to 6, and the computer is going to be worth this much, 4699 times 0.764388. You could have rounded a bit there to the power of 6. So again, chuck that in your calculator and you get out $937 and I get 33 cents. It'll depend on your rounding. Now the schedule's given an answer to the nearest to the nearest cents, which I think is a little bit silly. The computer's value's given to the nearest dollar, and so I would round that to probably just to 937 and just say what I'm doing, to nearest dollar. Or maybe I'd go to $937.30. But we're rounding anyway, so I feel better about going to here. It doesn't matter. Okay, on to the next one, which is far more pure algebra. So here it is here. We have to make P the subject of the formula here. So I'll write it out really big. 81 to the power of all of this weird stuff that has no useful purpose in life, but sometimes that's okay. There we go. So that's equal to 243. The key to this question is spotting that this is a power of 3 and this is a power of 3. And once you see that, the whole thing just kind of falls apart. So 81 is 3 to the power of 4. And 243 is 3 to the power of 5. Now, we've got 3 to the power of 4 times px over q minus 3 is equal to 3 to the power of 5. Working with the power on the left-hand side, that works out to be 4px over q minus 12. And the power on the right-hand side is equal to 5. Because I've got the same base, the powers must be equal. So suddenly this question looks really, really easy. All we've got to do is to make p the subject of the formula. So we get 4px is equal to 17q, and p is equal to 17q over 4x. So there we go. If you got all of that, that was a T tick, an excellence tick for getting the whole way through. I'm just trying to see if that's not how the schedule did it. The schedule did it using logs, and so you could have done it using logs as well. I reckon it's easier just to go with spotting the common base. So if you've got questions about how to do it using logs, just leave me a comment or send me an email. Thanks for watching.